What's up, everybody? Welcome back to another live stream from Scalar Learning, weekly Wednesday live stream where we are tackling SAT problems from Khan Academy as per usual. But I got a couple announcements to make before we start, which I'm very, very excited about. Okay, announcement number one, I just released a new channel trailer yesterday. Even if you guys have already subscribed, I'd love it if you check it out. Give me your thoughts. If you haven't subscribed, check it out. And then subscribe if you want to get more up-to-date information on everything math related for standardized tests. And also click the like button for this video if you could, if you do enjoy what I do and like what you see. My second announcement is after many, many requests to upload a set schedule with set times, I'm finally doing that. But moreover, starting this week, I'm just putting the finishing touches on the schedule and my new background for my YouTube channel. I'm going to be now releasing an ambitious 5 videos a week, which I know sounds crazy. And I think it could be a little bit overwhelming, but I have a plan and I want to do it because I want to augment the content on my channel, not just having SAT content, but also ACT regularly and ICE, which is the independent school entrance exam. It's a big test in California, especially for kids trying to get into middle school. So I want to have those components. And then last but not least, I'm adding a weekly Friday study tip every Friday. And so that schedule is going to be out hopefully by tomorrow. And we're going to be off and running by Friday with the new schedule. So I hope you guys look forward to that. I'm excited about it. It's going to be a lot of work, but I think it's going to be great and it's going to be really valuable. Okay, let's jump into the Khan Academy section, which is, what am I doing today? I am doing radical and rational equations. Radical and rational equations. Here we go. Now, as per usual, and if you haven't seen the channel, so you don't know, but I'm seeing these problems for the first time, which is part of the fun. I'm solving them on the fly in real time, which I have found gives students the best chance at understanding the problem-solving process and really getting to, in the flow of solving these. So let's do this one first together. We got the square root of 6x squared minus 50 equals 4x minus 10. What is the sum of all the solutions? Okay. So first of all, we're going to assume, but maybe incorrectly, that there's 2 solutions. There may not be. But how do we solve something like this? Now, these are incredibly hard problems. I've noted this on previous practice streams where I'm going through Khan Academy problems of this level 3, level 4. And people ask all the time, is the real SAT actually this difficult? Is it this hard? And my answer is no. I think what's happened is with the higher level Khan Academy problems, they've diverged from the SAT. I still think it's worthwhile to do the problems because it gives you more concrete skills. But are they accurate representations of what I've seen every single time I've taken the SAT? No, definitely not. So use this as training ground, but the real representation of the actual difficulty will be found on the 8 practice tests from Khan Academy, which I've solved in various videos, as well as if you can get your hands on any of the old past previous exams, some of which I've also gone over on my live stream. So check that out. All right, here we go. So first we got to get rid of this square root, right? We're trying to isolate x, of course, but we don't like things being trapped under square root. So we're going to start by getting rid of that by squaring this side. Have to do the same to this side as well, so we square both sides. Now I release this because squaring a square root just removes it. Now I have 6x squared minus 50. And then squaring this is really foiling it. Okay, so we foil. 4x times 4x is 16x squared. 4x times negative 10 is negative 40x. 4x times negative 10 is negative 40x, and so we're adding those to get a negative 80x. I'm consolidating some steps. And then negative 10 times negative 10 is 100. Okay, now let's bring everything to the same side and set everything equal to 0. You should instantly go for that move to isolate and set to 0 when you see a quadratic like this. So I'm going to move everything to the right side. It's a little bit easier. And I'll even add 50 to both sides, add 50 to both sides. So we have 0 equals 16x squared minus 6x squared is 10x squared minus 80x plus 150. Okay, now I can actually, before I do anything, I can divide everything by 10. 0 divided by 10 is 0. So now I have x squared minus 8x plus 15. Now let's see if I can factor, which I'm sure I can. This becomes -3 and -5 because those multiply to 15 and add to -8. That's what we're going for. We're going for numbers that multiply to this and add to this. So my two solutions are where this is going to equal 0. When x equals 5, it's going to knock this whole thing out to 0. And x is also going to equal 3. When x equals 3, this is going to go to 0 and knock out everything. So my two solutions are 5 and 3. We could add them together and get 8, but we can't be so hasty. Before we come to that conclusion, we need to come back to this original equation and make sure both of these solutions work. I have a feeling one of them won't because they do this all the time. So first I'm going to plug in 5, and that's 5 times 5 is 25 times 6 is 150 minus 50. Square root of that is square root of 100, which is 10. And on this side, I get 4 times 5, which is 20 minus 10, which is 10. Okay, so 5 is good. Now let's try 3. If I plug in 3 here, I get 3 squared, which is 9. So I get 9 times 6 is 54 minus 50, which is 4. Square root of 4 is 2. And then over here, I plug in 3. I get 4 times 3 is 12 minus 10, which is 2. Actually, both solutions work. Surprise. And then we do add those together. They said the sum of all solutions, which is why it's extra tricky. 5 plus 3 is 8, and that should be correct. All right, good. Next. What is the sum of all the solutions to the above equation? We have 3w over w plus 4 minus 8 over w equals 1. So first of all, to solve this, we need to get common denominators. That's how we're going to consolidate everything. I'm going to get a common denominator of w times w plus 4. Essentially, we're multiplying these two distinct denominators, and we're going to get a common denominator that way. So this one, I'm going to multiply it by w over w. This one, I'm going to multiply it by w plus 4 over w plus 4. I'm allowed to do that because I'm multiplying by w over w, which is 1. W plus 4 over w plus 4, which is 1. This side, we multiply by the entire thing, okay? W times w. Actually, no, sorry, we don't have to do that. We can just leave that alone because that's on the other side. All right, now, no. We do want to do that, sorry. So we're going to make this into w times w plus 4 over w times w plus 4. All right, you'll see why in a second. I could have left it alone as well, but this is how I like to do it. So now I have this nice thing where everything is over the same denominator. And when that is the case, only in an equation, not in an expression, but on an equation where there's an equal sign, now I can just cross off all of those guys. And now I have w times 3w minus 8 times w plus 4 equals w times w plus 4. Okay, now let's simply isolate w. So we're going to, first I'm going to distribute here. So this times 3w is 3w squared minus 8w, and then distribute that minus 32, right? Negative 8 times 4 is negative 32 equals w squared plus 4w. All right, now I'm going to consolidate. So I'm going to move these guys to the left side. Subtract w squared from both sides. Subtract 4w from both sides. Remember I said we're going to try and isolate by setting equal to 0. Negative 8 plus negative 4 is negative 12w. Minus 32 equals 0. Now again, I don't have to do this, but I can simplify and make my life easier by dividing everything by 2. And then I get w squared minus 6w minus 16 equals 0. And now we just factor. It's the same thing. What is the sum of these solutions? Is this factorable? Hopefully it is. 2 and 8. Yeah, 2 and 8. So we can do, so again, to multiply to negative 16 would be negative 8 and positive 2, and then also negative 8 and positive 2 add to give us negative 6. So these are our two solutions. And now we have a solution of where w equals 8, because 8 will make this thing go to 0, and where w equals negative 2. And then we just need to make sure that both of these are valid solutions. So again, I'm going to plug them into my original equation, but I don't have to go through the whole process. I just got to make sure that neither of these solutions gives me a 0 in the denominator because I don't have any roots. That's what I have to worry about. 8 does not. That'd be positive, whatever. -2 does not. That'd be 2. That'd be -2. I'll quickly mentally, just for fun, make sure that these are good solutions. 3 times 8 is 24 over 12, which is 2. Wait a minute. Oh, 8 does not work. Oh, yeah, it does. I'm sorry. That's 2, and then -1 is 1. And then -2 is -6 divided by 2 is -3 minus -4, which is +4, and that's +1. Yeah, both work. So now we add these two. 8 minus 2 is 6. And we should be good. All right, next. Same deal. All right. Just a little bit more complicated. 2x over x plus 3 minus 4 over x minus 2 equals -3. So common denominators, this one I'm going to multiply by x minus 2. So then the denominator will be x minus 2 times x plus 3. This one I have to multiply by x plus 3. Okay. And this one I multiply by both of them. Okay, when everything has the same denominator, we can say goodbye to the denominators. And that's really nice, much easier. Now I have x minus 2 times 2x plus 4 times x plus 3 equals -3 times x minus 2 times x plus 3. All right. Now let's distribute. 2x multiplies and gives me 2x squared minus 4x plus 4 distributes, and we get 4x plus 12 equals, this is a little trickier. Let's first figure these guys out. This becomes in the middle x squared plus x. I'm doing 3x minus 2x plus x minus 6, and then we distribute this guy. Boom, boom, boom. -3x squared minus 3x plus 18. So there's a lot of room for mistakes. I mean, look at all the work I'm doing. Oh, look, we can combine these guys. That's pretty good. They cancel out. -4x and 4x. There's a lot of room for error, so you got to be pretty careful. I'm going relatively quickly. I have confidence, though, because of the amount of practice I've had. We got to be really careful here. Okay, now let's consolidate. Let's bring these guys to the other side. -2x squared, -2x squared. And let's bring this guy over here, -12, -12. And then I got 0 equals -5x squared minus 3x plus 6. And now we got a factor. This is not factorable in a nice way. I mean, this is going to be kind of a pain. First, I'm going to multiply everything by -1. I don't like that first term being negative. The nice thing is we can get rid of that by multiplying everything by -1 and just flipping the signs. It's allowed. -6. We can do this. We can probably figure this out, but I'm going to show you how to use the star method to figure out difficult factors like this when you have an a term that's not 1. I'm just making sure. Yeah. Okay. So if we have an a term that's not 1, we put our a term here and here. We put a times c up here, which is 5 times -6, which is -30, and we put our b term down here. Now we come up with values that multiply to -30 and add to +3. So let's see. Oh, I wonder if that's factorable. It may not be. It should be, right? Let's see here. 10 and 3, no. -3x, -4x, 4x. 2x. Hold on, let me just make sure I didn't make any mistakes up here. 4x. Oh, I made a mistake. Aha. This is supposed to be. Do you see that minus? I missed it. So what that changes is this is actually these don't cancel out. This is actually a minus. Hold on. Let's. So this becomes a negative 8x. Everything is the same, except now we have to get rid of an 8x as well. Okay, right? I think that's all I'm... Oh, no, that becomes a negative 12 as well. Just trying to do this expeditiously. Normally I would just restart. Is it the smart way to redo this? But I think I can do this. So now we're adding 12 to both sides. Adding 12 to both sides. So this changes it quite a bit. Now we have plus 5x. Okay, and then we have plus 30. There we go. Let's see. So now the new... Oh, now we can divide everything by negative 5, so we don't need the star method. So if I divide everything by negative 5, again, 0 divided by negative 5 is that. I get x squared minus x minus 6. Now this is definitely factorable. Okay. X. What multiplies to negative 6 adds to negative 1. That's negative 3 and positive 2, which makes my x values negative 2 and positive 3. Okay. Because I had some errors in this one and I went back and I kind of changed them, I want to make sure that these work. So I'm going to actually go through the process of plugging them in up here and being positive that we're doing the right thing. And so first of all, I'm going to plug in negative 2. Here I get negative 4 over 1. Okay. Minus negative 4. And then it becomes plus 1, which is negative 3. Okay, so that negative 2 works when I plug it in here. I get negative 3 equals negative 3. And then 3, I get 6 over 6, which is 1. Plug 3 in here. 3 minus 2 is 1. 4 over 1, negative 4 because of the minus. So it's 1 minus 4 is negative 3. So both of those answers work. What is the sum of these values? Negative 2 plus 3 is 1. Oh, I should say, by the way, this problem and number 2 actually are more similar to what you could see on the SAT. These are reasonable problems from my experience. They're just incredibly hard, but it is what it is. Same dealio. 5 over k minus 2. So now hopefully you're kind of getting the hang of this. 2k minus 2 over k minus 1. All right, check it out. I'm going to multiply this guy by k minus 1 over k minus 1. This guy by k minus 2. K minus 2. And this guy by k minus 1. K minus 1 over k minus 2. Okay, all the same denominator. Let me make sure I didn't make any mistakes. And that minus sign is dangerous. Can't forget about that. All these guys go away. Now I have k minus 1 times 5 minus, that's what I missed last time, 2k minus 2 times k minus 2 equals negative 1 times k minus 1, k minus 2. All right. Let's simplify. So this is 5k minus 5. Distribute that. This is minus. I'm going to keep this in parentheses because this minus is going to distribute eventually. It's 2k squared minus 4k minus 2k, which is minus 6k. So I'm doing this plus this. And then negative 2 times negative 2 is positive 4. All right. Equals. Same thing, I'm going to keep that negative 1 out here. This is k squared. And negative 2k plus negative k is negative 3k plus 2. Now let's distribute these negatives. 5k minus 5 minus 2k squared plus 6k minus 4 equals negative k squared plus 3k minus 2. Now let's consolidate like terms. We got 5k and 6k is 11k. So I have, and then we got negative 5 and negative 4. So I have negative 2k squared minus 9. Oops, sorry. Negative 2k squared plus 11k minus 9. I'd like to do the k's first. Equals negative k squared plus 3k minus 2. And then we're going to bring, let's go to the right side. So I'm going to add k squared to both sides. Minus 3k from both sides. And then add 2 to both sides. And now I have negative k squared plus 8k minus 7 equals 0. Multiply everything by negative 1, k squared minus 8k plus 7 equals 0. And this can be factored nicely into k minus 1 minus 7, because negative 1 times negative 7 is positive 7, negative 1 plus negative 7 is negative 8. And my solutions are 7 and 1. That's it. Neither of these set the denominators. No, look at that. 1 sets that denominator to 0. So 1 is no good. 7 is our only answer. But before we do this, let's just even make sure I didn't make a mistake. So let's plug 7 in here and make sure it works. This becomes 5 over 7 minus 2, which is 5, minus 2 times 7 minus 2 over 7 minus 1, which is 6. So this becomes 1 minus, that's 14 minus 2 is 12 over 6, which is 2. 1 minus 2 is negative 1. Okay, so 7 does work. 1 clearly does not. Yeah. See how they try and throw a little curveball there? Okay. Last but not least, number 5 is this one. And look, it looks more complicated, but it's actually easier. I'm going to show you why. So here we've got 4n over n plus 3. And remember, the goal is we want to get common denominators. And this one, although it looks weirder, is actually better. Our common denominator is going to be this, n plus 3 times n plus 4, because that's common to both of these guys. And which means we don't have to do anything to this one. This one's got the denominator we want. This one I'm going to multiply by n plus 4 over n plus 4. And this one I'm going to multiply by n plus 3 over n plus 3. And then we go boom. And now we multiply. So now we have 4n distributed, 4n squared plus, oops. And then that distributes, but the negative distributes with it. Okay, so it's negative 3n squared minus 9n equals 3n minus 3. Boom. Boom. Like terms, 4n minus 3n squared is n squared. 16n minus 9n is 7n equals 3n minus 3. Subtract 3n, subtract 3n, add 3. Well, hold on. Let's back up because there's nothing to add it to. Just give me 1 second. N squared plus 4n equals negative 3. Now we'll add 3 to both sides, and you'll see we just get n squared plus 4n plus 3 equals 0. This is really nice. It's definitely factorable. And we got n and n. What multiplies to 3 and adds to 4? Positive 3, positive 1. So my solutions are n equals negative 1, n equals negative 3. But now we got to plug them in. I already can see negative 3 is no good because negative 3 sends that denominator and that denominator to 0. Negative 3 is out, just negative 1. Just for fun, it's got to be negative 1 because, wait a minute. I thought you can't have negative answers for these. I thought that was an issue. Okay, well, let me just quickly plug it in and make sure. So negative 1, that'd be 2, or that'd be negative 2 over negative 2 plus 3 is 1. So this side evaluates to 1. This side evaluates to 2 times 3 is 6. Negative 6. Ooh, what? Hold on. We have a problem. It's gotta be one of these solutions, right? I don't know. Okay, hold on. 4 times negative 1 over negative 1 plus 3, which is 2, minus 3 times negative 1, which is negative 3, over negative 3. Negative 3 plus 4 is 1. So this is like negative 2, right? Negative 4 over 2, negative 2 plus 3. Oh, yeah, that equals 1. And then on this side, we get 3 times negative 1. Wait, did I just mix them up? Hold on. Back up, back up. I think I just put in negative 3 instead of negative 1. Okay, so then we have minus negative 3, because 3 times negative 1. Here, let's do it like this. 3 times negative 1 over negative 1 plus 4, which is 3. So this is negative 2. This is negative 3 over 3, which is negative 1, positive 1 plus 1. Yeah, which is negative 1. Now let's do this side. 3 times negative 1 minus 3 over negative 1 plus 3 times negative 1 plus 4. Negative 3 minus 3 is negative 6 over 2 times 3. Yeah, okay, it's negative 1. So negative 1 equals negative 1. So this should be right. I thought that you don't usually have negatives for these free responses, but that could be totally incorrect. Let me see if I can pull up. I have one of these old tests on my computer. Let me see if I can find it. Where would it be? No. Hold on. There we go. Question and answer service. Let's see if it's this one. Okay, I'm just going to double check very quickly. I solved this test already live before. I want to look at the grid-in instructions for the math. Oh man, where is the math? It's way down here. Here we go. Okay. They give those, they give these, and then we go to the grid-in. I love the note calculator section. It's so short and fast. It's like a quick sprint. It's pretty fun once you get comfortable with it. All right, here's the grid-in section. See, that's right? There's no question has a negative answer. All right, that's what I thought. Because you can't even put in a negative symbol in the front. So, like, this just goes towards my point that sometimes these questions, they're not in line with the College Board standards. Because, again, I've mentioned this before, but I went to an entire talk where they describe the divergence between the SAT problems from Khan Academy and the College Board standard ones when the two, I think they like unofficially split, or the College Board essentially backed off their supervision. So now you see these issues emerging where little indiscrepancies like that could be potentially confusing. But anyways, hopefully that makes sense. At least you understand the principle. Let me just quickly see if I have any. Uh-oh. Hopefully, is this still streaming? Hey guys, hopefully you can still see me. You got a 1170 and sending colleges with SAT scores. Oh, man. I don't know. I'll put it like this, Piyush. It's not gonna be easy. I can tell you that I have coached students and helped them with their entire college applications when their SAT scores were lower, and I know they had awesome rec letters and they had banging essays. And from my experience, it gets pretty difficult. It does get pretty difficult. I would say if you're essentially like 80 points below the lower 25th percentile. It's possible, don't get me wrong, but it's gonna be tough. So that's what I would say definitely have some backups where you're more centrally located within the 25th to 75th percentile. Okay, guys, that's it. I gotta run. I gotta start my day of tutoring. Hope this was helpful. Again, the new schedule's going live probably tomorrow or Friday, one of the two. But anyways, the first regularly scheduled video will be released on Friday, which will be a study tip, 60-second or 1 minute study tip. Can't wait to launch it. Again, guys, check out my trailer if you haven't seen it yet. I just launched it yesterday, and I'm excited about it. Also, please like this video if you enjoyed it and you found it useful, and click the subscribe button if you haven't done so yet. Thank you guys so much. Have a great day. I'll see you next time. Take it easy.